you will also find in the scene a free flight controller script and crosshair script. These are used, well, they're demonstrated here in this little video. While this is playing, let me say a couple of things about the limitations of Bluetooth. When you're working for a particular application, you're going to have to choose early on which platform you're targeting. Working Bluetooth through a cross-platform implementation remains quite a challenge. Unity at the moment doesn't have any plans that I'm aware of to integrate this into it. And the option in 2019, Unity 2019, to remove the .NET scripting backend certainly complicates things or slows things down for Bluetooth developers. That said, we're using Unity 2018 and we can still use the C# projects option in the build settings, and that was enabled earlier. We're now in the blue brick scene, and we can start trying to figure out the Bluetooth connection script. This only has one other option. It's connected to this text pane above it. And we can start to look at this. You'll notice straight away that a lot of the code is grayed out. We're going to develop this in two parts, in two stages. The first thing we'll do is put in the Unity code above. This is how it was grown. And you can see we have an address book that is defining a ulong, that is the Bluetooth address, and a string, which is going to be the name of the device. And we have a reference to the Unity text. This is where we're going to update the user interface. When we start, we call a single function, which is to set up the watcher. The other events that come later will all come from the Bluetooth advertisement watcher receiving something from a device, and that will be the trigger for all the other actions. In this setup advert watcher method, you can see that the code is all under the top level condition of Windows UWP. This is our interface between the two halves of the code. So this is our input. The output will be a set of address book entries, and these will be printed through this function onto the UI panel. So really, as early on as possible, when you're building an application that has Bluetooth components, you really want to build the scene. Since we're using C# projects that I mentioned here, we won't be able to build and run it. We'll have to do that manually. Choose a standard folder. When the app has been built, we want to go into the subfolder that is stored in and open the solution that's there. Now that it's loaded, you can see that all of the code between the top level Windows UWP conditional statement is now visible and can be debugged. So let's start to look at what all this means. As I said, the point of entry for all of the information is the Bluetooth advertisement watcher, and this is created here at the very beginning. It has a few options set, and it needs to have two events attached to it for it to work properly. The first, the onReceived event, is where the data comes in, and another is a notification of the watcher stopping. This is the event that is called if Bluetooth is not switched on when you try and run the application. And so at the very bottom, I've added this this line to flag that the Bluetooth may be switched off. The onReceived function simply takes the Bluetooth address from the arguments and passes it to another function, and we'll look at that function now. When we receive information from a Bluetooth service, we distinguish the name and the address of that. If we find, as we often do, that the length of that name is 0, then we assign the address in string form as the default value. We can then add this as a key value pair to our address book, which happens in this function. But we only continue with this if the item is not already there. I've included another optional part that you can add into the handle watcher function. And what this does is to attempt a connection each and every time there is an advert received. What this attempted connection will do is often it will give a name value where previously one was not there. So while the device will not connect in most cases, you will be able to read its name and update the address book with that name. The next thing that happens here is that we set the flag address book has changed to true. What this does in the next frame is to alert the main loop that there is new information. The text property of the user interface is then updated, and the bubble menu is given some values which it can show. This is then turned off so that you don't have lots of these things happening in a second. With the project running, we can see lots of entries in the address book. We can see that some are identified only by their addresses, others have names. By right-clicking on the blue brick, we can see the bubble menu functionality. And here again is a bit problematic having so many. So now that we can find devices, we want to be able to connect to them and take data from them. So how do we go about connecting? Well, the first step is usually to read one of the characteristics from the device. Often this is enough to maintain a connection, but sometimes there may need to be some kind of long loop to make sure that this is checked in case the devices disconnect. Bluetooth low energy devices will tend to disconnect because they prefer to be in a low power mode. Two types of identification are needed. There is the service ID that tells us the collection of characteristics, and then there is the specific characteristic ID. You can see them here in the code. I've taken these from the sketch I showed you earlier, and near the top of this we can see that there is a service ID defined, and a couple of lines down there is also one for the IMU characteristic. And these will have been taken from the documentation, or they can be used arbitrarily so long as they don't conflict with existing ones. They must all be unique. Since we're working with a single Bluetooth connection, but we would like to maintain connections to many devices, it is sensible to have multiple instances of the Bluetooth classes that we can use. The bubble click handler does just that. So while it relays messages that it's been clicked on back to the menu system, it is also able to connect to and pair with the devices. It uses these two functions. The first begins with a call to get the device object from the address. If the device object we get back is not null, then we can populate a device information object with the results of the pairing. Once we're paired, we stand a much better chance of getting data from the device. So how do we go about doing that? Well, the first thing we need to do is notify the main thread that there is new information, and we do that with this flag, device has changed. Up here in the update loop, this flag is received. We send a couple of updates to the UI component, and then we run this function, and this takes a device and it will link to an event system that allows us to collect data. The subscribe to IMU characteristic function is here. This performs actions in a sequential fashion. It first of all finds the GAT device service using one of the functions in the data handler, and I'll show you a bit more of that in a second. It uses an input of the Bluetooth low energy device, and it takes the GUID, the ID that we extracted from the Arduino sketch. This is the one for the service. If the result of this is not null, we can proceed and we can take the GAT characteristic. This is searched for within the service and again is referenced with its ID. We need to make sure that this is not null as well, and when that's the case we can send a notification to that characteristic of this type. It's also possible to unnotify a characteristic by using none. The data handler that houses these functions also has a delegate and an event that can send data back up once it's been received, and that is connected to the following function, receive IMU data, and that's just here below, and all that's doing is debugging one message to tell us how many bytes have been received. I'll just look at the notify characteristic functions for now, since that's the one we're using. That has a top level synchronous function here. This is referencing a lower level task that sits at the bottom. And what this is doing is making sure that the GAT characteristic receives the value that it was sent. The value changed event of this characteristic can be set during notification, and what that does in this context is to link to the receive data function. This receive data function takes the information about the value of the characteristic at that moment through the args attribute, and this is further defined by the characteristic value property. This is sent to an array and passed through the event system. The bubble click handler picks this up and the event is connected during subscription to this receive IMU data. All that's happening here is that we are reporting through the debug log the length of the bytes received. Since it wouldn't be fair of me to do all this hard work and not give you anything in return, I'm going to leave the conversion of this byte array into a quaternion, and the assignment of this quaternion to the local rotation property of the Bluebic, I suppose the transform, as an exercise for you to do. Good luck. We're now going to run the app and see if we can get some data from the device. And here you can see the device information. We have system name, some other properties about the pairing status. We can see where the icon and glyph icon are located. And then if we switch over to the debug log, you will see that there is a fairly constant stream of data coming through. So this concludes the tutorial. I hope you've learned a few things. I hope you see that hooking microcontrollers up to your projects is both achievable and within your means. I hope you find inspiration in these things. Through all the challenges, I have found it extremely satisfying, and I'm very happy to share this with you. Please enjoy the rest of the course, and feel free to get in touch if you have any questions about this tutorial or other AR elements. Thanks.